Hi, everybody. How's it going? Happy Friday. Have you had a good week? Yeah? You feel excited. Lots of excitement. It's been fun. Yeah, it's been a great week, and I'm glad to help you in one of the last few sessions to tell you a fun story. So today, we're going to do a talk that's a part of a series called the Zero to App Talks. And in this talk, we're going to build an application. We're going to build a universal translator with Firebase. And this is a talk I love to do on the road because I'm a monolingual person. I only speak American English, which can be challenging at times. But this can make it easier. But before I get into that, let me tell you a little bit about myself. Hi, I'm Jen. I am a developer advocate at Google, focusing on cloud platform. And I spend a lot of time playing with Firebase stuff as well. And in this role, what I do is I come and I get to tell you, all of you, great stories about stuff involving Google Cloud and Firebase products. And I also get to go back home with stories that I hear from all of you about what we're doing great, what we could be doing better, what you're interested in, to help us figure out what we should be working on to improve our platforms. So I always love hearing from all of you, whether it's a story about something awesome you created, or a challenge you're facing with a Google platform or API. So please do reach out to me if I can ever help. You can find me on Twitter. It's a pretty easy place to find me. Just drop me a DM. I'm miming codes. And if you'd like to, I don't have my website URL up there, but if you'd like to ping me via other channels, I'm also miming.com. You can find other ways of contacting me there. So we're going to be doing some code. But before code, let's do story time. Who here likes science fiction? A few hands went, okay, everybody's hands went up. Yeah, I figure that might be, some selection bias with that. I love sci-fi too. And it's actually been a big influence on me growing up. I watched a lot of science fiction, and it's one of the things that helped guide me towards engineering. I got to see all the cool stuff people were able to accomplish with technology. And one of my favorite science fiction series growing up was Star Trek. And Star Trek was really cool, partially because they had lots of really cool technology that allowed them to accomplish tasks, or I suppose to make the writing easier. For example, one of these technologies was this magic handheld device that would allow them to talk to anyone far away, which seemed really impressive. And it's kind of neat because we already have those today. Another technology that they had was they could just ask a computer. They could just, with words, talk to a computer, and then tea would appear. And that was really cool. And we've gotten part of the way towards that. Like, you can talk to computers, but tea does not always appear unless you count it arriving by, rideshare eats or something like that. But one of my favorite technologies of Star Trek was the universal translator, which I think was just there as a plot device to make it easier to write and make it easier for us to relate to aliens. But it was still really cool, because no matter what planet they landed on, and no matter who they were talking to, even if they had never had any contact with a species on another planet, after a couple words, they were already completely understanding each other with fully functional two-way communication. And that seemed like such an amazing thing, seemed so cool. And this is the kind of thing that I would love to have, because part of my job does involve traveling around the world and coming to developer events like this, and meeting other people in other contexts that are using our stuff. And I would love to have something to make it easier for me to communicate with them in their chosen tongue. So I decided to solve this problem in the way I solve all of my problems in my life, with code, specifically writing a mobile application. So that's exactly what we're going to do today. I'm going to guide you through the creation of the app to solve the kind of like universal translation problem. And you can kind of see you can kind of see the app. What our vision for it is, it's an app. You select your preferred language to both communicate out in and also to receive language in. So you choose your chosen language for that. You hit a record button, which is either big or small, depending on the platform of your choice, and you will speak into it. And what it will do is it will translate it to many different languages simultaneously. And then anyone else with a copy of the same app will hear it translated to the language that they selected. So that is the app I envisioned to solve this problem. And I'm going to solve it using Firebase, because Firebase is a great way to prototype mobile and web applications. So we'll spend a couple minutes talking about Firebase and the components we're going to use to build this application. So let's talk a little bit about like traditional mobile application development. If I wanted to write this app like a few years ago, the first thing I would probably do is start sketching out the app like I just described, and then trying to pick some back-end components to solve my problems. I'd pick relational databases, I'd pick some cache infrastructure, I'd figure out how I'm going to be sharding my data potentially, or sharding at the database layer. I'd probably have some third-party APIs I'm going to use, and I'd broker them through some VMs or processes running on those servers. And this is a great approach. It definitely gives me a lot of flexibility on how to scale and how to solve all the problems my app will solve efficiently. But it can take some time to get started. But there's other options because we're kind of in the future now. We have lots of different options for solving these problems. And Firebase gives us some interesting approaches to this. What Firebase does is it's kind of like a big bag of goodies that takes a lot of kind of the common tasks of mobile and web application development and gives you really good pre-built backends to solve some problems and a whole bunch of stuff in client libraries that take care of the heavy lifting of communicating with those backends. For example, do storing state and storing blobs, which are two of the features we're going to be using. But there's a whole bunch of other goodies in the goodie bag, everything from like static file hosting to, what else do I have on this slide? Remote configuration pushing, authentication, all sorts of other goodies, which are not always fun to keep re-implementing over and over again. And you might just want to use just one of these for an application, and in which case it will work great. But they also connect really well, and I guess the word is synergize. I never thought I would use that in a presentation. They have a lot of synergy with each other, so they're even more useful when you use more than one together. For this application, we're going to use 3 specific things from that goodie bag. We're going to use cloud storage for Firebase, which is a tool for storing big blobs of data. Particularly, we're going to use this. Specifically, we're going to use this to store the recorded audio of the user speaking into the app so that we can work with it in the cloud. We're going to use authentication, partially so we can just identify the users to our application so that they have access to their specific data, and also so I can prevent anyone on the live stream from jumping in on my app in real time, because that would not be very fun. Or it might be fun, but not for me. And we're going to use my favorite goodie from the Firebase goodie bag, which is the RealTime Database, which is actually the first goodie from the Firebase platform. It was one of the original products. And it is a backend that is built around transferring real-time data. So let's dig into a few of these in a little more detail. So cloud storage for Firebase. So dealing with like cloud storage and just general blob stores from a mobile app can be a little bit tricky at times because you have to figure out how you're going to handle the key brokering and how you're going to, for example, set limits on individual users uploading certain amounts of binary data. Getting all that access control can be kind of tricky. So what cloud storage for Firebase does is it gives you a nice default configuration so that you can just call the client library, store your binary data. It does a good thing by default. It'll send it up to a cloud storage bucket, which will then make it globally available for any other client anywhere around, being served up through all the different points of presence that cloud storage provides. And it also has all the client library components for automatically syncing to clients that care about it. So you don't have to spend as much time moving around those bits and stuff like that. So it's a problem that it's deceptively complicated, and it makes it a little bit easier. Authentication is another very important thing, especially if you want to restrict access to an application or you have data that is user-specific. For example, like user profiles, where you only want users to be able to edit their own profiles. Security is important. And Firebase Authentication is the kind of first step in building out that security framework for your apps, because you have to be able to identify users before you can figure out what they will have access to. And the way Firebase Authentication works is it gives you pre-rolled implementations for a bunch of different authentication schemes. For example, we have pre-rolled like backends for OAuth, like social login providers like Facebook, GitHub, Twitter, and Google. Like, has anyone ever rolled their own multi-platform authentication provider with OAuth? A few people. Was it fun? No. Oh, someone said that's the first time anybody's ever nodded. I think authentication is pretty cool too, but I did not enjoy building both a Twitter and Google authentication broker at one point. They use different interpretations of OAuth. But anyway, we've already done this with the Firebase authentication stuff. And we also have like username and or email and password authentication for users that don't want to do a social login. We added phone number authentication a few months ago, which is pretty cool. And there's client libraries for integrating with existing authentication systems. You can mint the JWT tokens to integrate with your SSO or any existing authentication system, which works pretty well. And one of the neat things about Firebase Authentication is each one of these login providers boils down to a unique identifier for that user across all Firebase services. And you can, if a user comes in via a different authentication flow in the future, you can, give them access to the same data because they're still identified as the same user to Firebase. And then finally, my favorite part, the real-time database. So the way the real-time database works is it's kind of like a big old ball of JSON in the sky. Because we all love JSON, right? Mostly nods, a few shaking heads. I guess it's an opinionated crowd about data storage formats. But I like JSON. It's convenient. It's pretty easily human readable. And so the way it works is you imagine all of your backend data as one big old ball of JSON. Your applications can write to certain nodes or subtrees. Anything you could put in JSON, so like booleans, strings, numbers, stuff like that. And then your clients will tell the real-time database what subtrees or what queries against subtrees they are interested in. And then the client libraries will work with the server to make sure that any client will always get push updates for the parts of that big old JSON tree that they care about. So we'll handle all of the synchronization, all of the background threads for the network transport, cache invalidation, which is never fun to work on yourself. We give you good sensible defaults for all that stuff. We also have APIs for handling both short duration offline, like driving through a tunnel, as well as long duration offline, like going for a mega hike across Appalachia or something like that. So you can configure like pinning and all that stuff for handling those offline cases too, which is also not very fun to roll your own. So enough talk about the Firebase stuff. Let's show it to you in action. Let's do some code. Sound good? Yay! Okay, so let me show you someone was especially vocal. I like code. So this is the starting application we have up here. Let me make it bigger so it's even bigger on the big screen. See if I can get Visor to cooperate. There it goes. That's pretty big. And it doesn't really do much right now. So it's just kind of a shell of an Android app, which of course means it's quite a bit of code because it's an Android app. And Android apps often have lots of code inside. But you can see the controls I described earlier where we have a spinner, a drop-down box for picking the language we want to speak and understand. We have a record button for recording an audio clip, and then any translated text to the global chat room essentially will be put here. So what we've already done ahead of time is I've already written the code that does like the recording, like taking the bits out of the media recorder and bringing them down to a local file on the Android device and all that kind of stuff. I've also gone ahead and set up all the Gradle dependencies for Firebase because that's not terribly fun to watch and sometimes it can take a while to download. So when you're going to get started by adding Firebase, actually taking a step back, this is a kind of a general flow I'll use for building applications if I'm going to be using Firebase, is I'll kind of wireframe out just the front end. I'll get the front end, I'll get it looking the way I want, and then I kind of get it working locally, like without much real behavior. And then I kind of add Firebase into it to wire the UI components directly into the real-time database. And then before I know it, the app's just kind of already working, which is pretty cool. So if I'm going to be doing that, if I'm going to be starting from this like UI wireframe, the first thing I'm going to be doing is pasting in some code that will go and get an instance of the different Firebase components I'm going to use. So I'm going to be using storage for the binary files. I'm going to be using authentication for doing all the authentication handling, and of course the real-time database for moving all of that fancy fun state around. Then I need to be able to handle, the first thing I want to do is I want to write all the data to the different Firebase services I'm going to use. So I'm going to be uploading a file to Firebase. So what I'm going to be doing here is I'm going to be using the references that I've initialized in the onCreate, and I'm going to come down to this upload file method, which it's called when the button gets pressed and the recording finishes. And I'm going to set up the references. So what I'm doing here is I'm getting a couple different references. First, I'm asking that storage instance for a reference, kind of a handle on a directory, to a directory in cloud storage called uploads. So just give me a handle on the uploads folder, and this is going to like establish the sessions and get everything ready to start moving data back and forth. And I'm also going to ask for a reference to the real-time database. And what I'm going to do here is you can give it a path to any subtree within that database. I'm just going to refer to the root uploads node. And then I'm going to call push. And what push does is it gives you a monotonically increasing globally unique identifier. It gives you a database ID. And this one is appending it to that path so that everything I write will write to that location. And what this allows me to do is have many clients that are writing at once and have all the stuff go in serially. And the client library will take care of like correcting for clock skew and all that other not fun stuff. So with those database references in hand, I'm going to upload the file to storage. I'm going to take, and I'm going to upload it. I'm going to name it. Well, first, okay, so I'm getting an upload ref, and I'm naming it based on that monotonically increasing identifier that I got from the real-time database. I'm also going to configure some metadata on that file. Then I'm actually going to push the bits up to the cloud. I'm going to get that recording from the local file system. I'm going to associate that metadata that I defined, saying like the content type and that kind of stuff, so that I know how to transcode it later. And the first thing I'm going to do is add a handler that will respond to failures. So if for some reason I am unable to upload, this method will get called. So this could be because of like something that happened on the network, could be because of an authentication failure. Anything that caused it to fail will trigger this, and it passes in an error object that I'm not actually using. I'm just toasting a message that says I'm sad. Then I'm going to add another handler, and what this handler is going to do is it's going to respond to a successful case. So in the case that I'm successful in uploading the binary of the recording, then I'm going to create an object, just a POJO, which I should probably convert this to one of those wonderful Kotlin data classes, but haven't yet. So I'm going to create a recording object that's just a POJO that I'm going to put a bunch of the metadata about that recording into. Then I'm going to take that and I'm going to write that POJO to the real-time database. So it's going to get sent up there, and it's just going to get broken down into an associative array of stuff in the real-time database. And I can use that for downstream signaling. So let's go ahead and run this application and see what it looks like. So we're going to run it on my Pixel. And let me bring up the database viewer for the real-time database, and let's see what happens when we try and use this application. So the Gradle build is running, so we'll do the dance while that happens. So when I fight with my coworkers and foam swords, like that comic Once Upon a Time said. And now we're installing the APK. This will happen a few times during this talk. Okay, so our application is running now. So when we hit record, it should be able to upload something to the storage, and then it should be able to, we should see it appear in the real-time database if that's successful. And my app crashed. It says it keeps stopping. Oh, I think I forgot to log out after I rehearsed. So let's go see why it crashed. And it says illegal state exception on the recorder. Uh-oh. I think Android forgot about some permissions I had set ahead of time. So I'm going to take just a moment troubleshooting this before I go in and move on to the next step. And then we'll fix this after the fact. So this is under, so it's asking for an application. We app permission, because I was lazy and didn't actually add the code that does the permissions the way you would expect. So it's up there, and it has the permissions for recording. So why are you grumpy, app? You were fine this morning. Let's give it one more kick. Okay, so we're gonna pretend that worked, and we're gonna keep on moving. Because the thing that would happen if it was cooperating is it would pop up the message that said it's sad. So if we go back down here, it would say, where did that method go? So we're below on create. We're down here in the upload file method. So what I hadn't done ahead of time is my backend was already configured to use Firebase Authentication. I was requiring clients to be authenticated as a user to be able to upload data to storage, as well as to be able to write stuff to the real-time database. So because those were set up on the back end and I hadn't actually authenticated on the front end, it blew up in a little fireball and should have just toasted and said, I failed to upload the audio. So the next step for that is to go up ahead and add authentication handlers to our app. So we're going to go up and we're going to add that, and we'll see if this fixes my application, which I don't think it will, but we'll find out. So we're going to go back up onto the onCreate method on our Android app, and we're going to set up authentication. And the way Firebase Authentication works is just the regular Firebase authentication libraries provide kind of low-level handlers for doing like all of the different passing of chunks of data around and keys and all that stuff to do the authentication. But they don't have a strong opinion about what the UI flow should be. So you'd have to kind of like, which makes it great for integrating into a UI flow you already have or styling it like the app the way you want to style it. But that's not always the case, especially if you're just hacking out an app quickly. So in addition to that, we have something called Firebase UI, which is a set of kind of default implementations for the UI flows for a bunch of different Firebase things. And I use this a lot for the authentication stuff. So the way they work is they will, for Android apps, they will, if you are not authenticated, you can start an activity that will handle the authentication flow for you. So what you do is you use the authentication handler to determine if the user is currently authenticated. And if the user is not authenticated, it's going to be equal to null. Also old-timey. And if the user is authenticated, then we can have our app behave as it would. In this case, we can have it listen for translations. But if the user is not authenticated, we want to authenticate them first. So we're going to put in a code snippet that takes care of that for us. So what this code snippet does is, it's a wide snippet. Anyway, so what it does is it goes and it calls a method on Firebase UI to start an activity for result. And then it will create the activity, or rather create the intent to create the activity that does the authentication flow for us. And what you do here is you set the different providers that you want to support. So in our application, I want to support email and password login and Google login. But I could put other ones there for Facebook or for my own SSO provider, that kind of stuff. So let's see if it just magically starts working again when I hit the run button. Otherwise, I'm going to go to the other app, which I've pre-prepared on another package name just in case this kind of thing might happen. Funny how that happens, isn't it? Hey, at least it starts. Hey, it actually started. I can at least show you the authentication flow. So I was not authenticated with this application, so it immediately took me over to the login flow. And this is the default thing. I can actually put some other metadata on the authentication flow to give the user some hints on the screen, but I didn't bother doing that. So we can authenticate. I can authenticate as my user, mimingcodes@gmail.com, and it's going to take me back to the application. And then we will see if it lets me record now, if it's magically started working. Nope, it stopped working already. Hopefully the other one works. Anyway, so now I'm authenticated, so I should theoretically be able to write objects to the real-time database and to storage. So let's actually see that in action on the other prepared application. So, this one's still recording. Oh, because the microphone, someone just told me that I had another application that had been recording for hours apparently, which locked out that resource and then triggered a case that I did not anticipate in my application, because mobile development can be hard sometimes. Let's see if that fixes it. Hello, world. So it won't actually translate anything yet, but we see that it was successfully uploaded, and we see that it appeared here, and this is the metadata about the file I uploaded. And if we go over to storage, we can see that there's an uploads folder with a bunch of files in it because I forgot to clear them out. But you can see that there's one from right about now. It's about 4.7 kilobytes of me saying hello world. But our application has not actually responded to it. So I've sent data up to the cloud so I can do stuff up there. But my application's not reacting to events in the cloud yet. I'm only writing data. I'm not reading it. So let's implement that part next. So what we're going to do is we're going to go down to this listen for translations method, which is the method I call when like my application is set up and it's ready to start receiving data from Firebase. So listen for translations. What we're going to do here is grab another snippet of code, and we're going to do something we do a lot when we're using the real-time database. We're going to get another reference to a location on Firebase. This time, we're going to listen to the path translations, which is where all the translations are going to end up. And then the next snippet, what we're doing is we are adding an event listener. Let me see if I can make this a little wider. Fighting visor here. It does not want to today. It is a silly thing. Anyway, okay, so here it is. You can actually see all the code. So what this one is doing is we're doing a query against that tree. Specifically, we don't care about the stuff that was uploaded an hour ago or a day ago, because it's all going to be up there. We only care about the stuff that people are currently doing. So we're going to add a query, a very simple query, to the limit to the most recent one object that's been uploaded to translations, or it's been written to translations. So what this will do is when we first connect, we'll get the one most recent one. And then as people continue to use the application, we're going to continue to get callbacks called whenever another one of those things appears. Every time one appears, it's going to send us one down. And it is a child event listener, which means that we're going to give the path just above where we want. And it's going to give us, whenever a new child is written up there, we're going to get callbacks for a variety of events. So there's a bunch of events that I didn't bother implementing, but in production I actually would. Like for cases when the children get deleted, what should I do? Should I display an X on the screen? If the child is changed, but we're just doing the child added. So we're only handling the case where a new one is written. And what we're going to do is, in this method, which just gets called whenever a new object appears, the first thing we're going to do is take the snapshot. The snapshot comes in whenever you get a kind of a read event from the RealTime Database. And it's an immutable snapshot of the data at the time the callback is called, at the time the event occurred, essentially. So if things change while your callback is running, it's still going to stay the same, because otherwise that would be crazy. And it has a bunch of metadata in there. One of the pieces of metadata is the key, which is going to be the same key that we defined way above on that push method as they're propagated through the system. And then once we have that key, we're going to listen for the language that we have picked on the spinner. So let's go down into here and let's implement that. So what this one's doing is it's null checking the translation key. If it somehow gets called by a null one, it won't do sad things. And then what we're doing is we are creating another listener. So we're taking the language that our application has selected and the key that we got from the previous method, the previous listener, and we are listening for translated text to the language we have configured. And this is a model you will do a lot, is as you build out this kind of stuff with the real-time database, the subtrees that you care about will change a lot, will move around based on events in your application. And the listeners themselves are actually very cheap to construct. So it's not unusual for a more feature-rich application to have hundreds or even thousands of listeners. Sometimes they'll be changing changing on the second or minute. They're very cheap as part of the way the client library is constructed. So don't worry about creating a bunch of listeners. But try not to leak them. If you leak them out, you end up syncing data you might not want, and you might be sad then. So then what we are doing with our listeners, we're adding a value event listener. And the value event listener will, so the previous one listened for when any children got added to the node just below. This one is listening to changes in the state of anything in that subtree. And whenever anything in that subtree changes, we're going to get a snapshot of the whole subtree sent back to our method. And what we do here is a pretty simple thing. We get the data out of the snapshot as a string, and then we pass it to the platform, the Android native text-to-speech. So let's go ahead and see if this runs. Let the APK install. It's getting faster. It's funny how that happens. So now what we can do is we don't actually have any of our translation stuff written yet, but I can totally pretend to be it. So I'm using this database viewer to add it, and we need a fake key. Then under that, we are listening for, it's currently selected is English, and then hi everybody. And hey, it appeared right there, which is pretty cool. And it's a value listener, so it'll respond to changes automatically. So I can even change this, and it'll change pretty fast on the client, which is pretty cool because this one's going over wired Ethernet and that one's going over conference Wi-Fi. So It moves pretty fast as a round trip to the Firebase servers, which is pretty neat. Okay, so now we have our client, which works and can both read data from Firebase as well as write it, or can write data to Firebase, the metadata about the upload and the binary data itself, and it can also respond to changes in the real-time database. So, like, we're done, right? Not really. I typed the translation myself, and as I mentioned at the beginning of the talk, I'm sadly very monolingual. I'm ashamed. So I can't actually implement this by typing myself. That, and I would get pretty tired after a while. So this is where we can pull in other cloud platform services and other fancy serverless stuff, new shiny fun things, to make this work better, to actually implement the translation features. And we're going to do that in, of course, the trendiest way possible today. We're going to be adding machine learning. But I don't have time to train my own model or anything, and I'm not very knowledgeable in that area anyway. So I'm going to take advantage of some of those pre-trained machine learning APIs, which are really just kind of a REST API that you can send requests to, and they will do some work for you with magic, and then you get back some slightly different data that is magically more useful to you. Specifically, we are going to be using the Cloud Speech API, and the Cloud Speech API will take our audio recording from the app and then transcribe it into text. And it supports a whole bunch of languages, which is great. Then we're going to take that transcribed text and we're going to send it over to the translation APIs, which will translate it into all of the languages that our platform supports. And then we're going to pass that back to the client so it can speak the language that the user has selected. At which point it seems like the problem is already solved. We can just wire up those cloud APIs to the client and everything will be great. Kind of. Because it turns out that if you put something into a mobile application or on client side, especially something as valuable as an API key, or if you're writing a game like the cheat detection code or something like that, someone is going to reverse engineer your mobile application, get that stuff out, release it to the world on some forum somewhere, and then you will be sad because you will run out of quota on the speech API and your app will stop working and you'll have to pay for someone else's use of your speech API, and that's sad. So mobile applications have a lot of secrets is what I'm saying. And you need a way to keep that secret away from the prying eyes of would-be not nice application users. We also have to deal with the case of CPU load. So mobile devices are great. They've become faster than ever. The CPUs are ridiculously fast now, but the batteries are not much bigger than they were several years ago. So I could put the models on the device directly and do a lot of this heavy lifting on the mobile device, but then my phone might be hot while I'm using it, and then the battery will die fast, and my users will be sad, and they won't use my app. So we also want to be conscious of the amount of CPU time. And also, I'm building an Android app in Kotlin today, but we might want to support multiple platforms. We might want to write an iOS app, which has a very different development model. And rather than hire 2 teams to write our app in parallel and try to somehow keep everyone in sync and get feature parity and some kind of design parity, I'd like to be able to do as much of the stuff with a single chunk of code as possible. And there are different solutions for this. There are frameworks for taking code and putting it on multiple platforms. But there's another way too. What we can do is, traditionally what we might do for this is spin up some servers and push all of this work to the cloud. Spin up some backends that do the heavy lifting, that broker our communications with the APIs and keep the API keys secret and away from our users. But if our application is successful, we're going to end up exactly where we didn't want to end up, managing a whole bunch of servers. And I'm working for a hipster startup company. I want to continue moving fast and focusing on the front end and the user experience for my application. And at Google, we've been doing serverless for quite a while. Way back in 2008, we launched App Engine. And we've been doing a lot of serverless stuff for a very long time. And we've been doing a lot of serverless stuff basically internally for even longer. And over the years, we've learned a lot about different serverless technologies. And that's where new stuff becomes available to everyone. And specifically, one of the newer things I've been using, I guess it's not that new anymore. It's getting close to a year old now. But it's really fun for dealing with problems just like these. It's Cloud Functions. So because we're just doing a small amount of brokering and have a small amount of secret data and not really that much complexity in the cloud, but potentially big spikes of scale, Cloud Functions is a great way to solve our problems. So let's switch over to another language, away from Kotlin land, away from Android Studio. And let's bring up IntelliJ. And let's write some Cloud Functions. So this is kind of where you would start if you were writing a Cloud Function that used this stuff. We have a bunch of dependencies we're pulling in. Yay! Cloud Speech API, Cloud Translate API, all of our different API keys for making those calls, and one little boilerplate method for handling the different representation of language codes between iOS and Android. But we get started. We have very little boilerplate code, which is kind of cool. It's a neat place to start because you can basically start with an empty file, which is something you don't see a lot on platforms these days. So the first thing we're going to be doing is we are going to be creating a JavaScript function because it is Cloud Functions, right? And this function is going to be, when you use Cloud Functions with Firebase, there are a bunch of different events you can respond to. And the Cloud Function will be called whenever those events occur. These could be like webhook events, like you have a URL, when it gets hit, the function runs. But there's also some that tie into different parts of Firebase directly. So for this one, I am writing something that is triggered when there's an event on the RealTime Database. So it's a database trigger, and then I give it a path, a subtree, that I care about. So whenever something happens on a path that matches this query with a wildcard, the function's going to get called. Specifically, whenever something happens on the uploads node with any identifier, it's going to call this function, specifically when it sees a write event. And writes will include changes as well as new creation. And then it's going to give me an event payload that contains a bunch of goodies. The first thing I'm going to do is unpack that event payload and put it into more convenient to use things. So the payload is going to come with, for example, the language and the sample rate and all the other stuff that's within that node. So what I'm doing is I'm reading the object that got passed into the function from the database. The next thing I'm going to do is take that data and remunge it into a slightly different format. So I'm going to take it from my mobile application format that I push to the RealTime Database. I'm going to change it to a format that I can send to the Speech API. So I'm unpacking bits from one format, packing them into another. And then I'm going to point the function at the recording where it lives in cloud storage. So I don't have to actually download the data, like I don't have to pass it through or anything like that. I can just point it to the location I've already uploaded it. Then I'm going to run my recognize event. And that's going to give me a promise. So when that returns, then I will have the recognized transcribed text. I'll take that, and I will get another reference to a location in the Firebase Real-Time Database. And I'm actually interacting with it through the admin SDK because I'm running in a trusted environment, which allows me to bypass a lot of the security rules and stuff like that. Because this function is in a trusted environment, I'm giving it access to all of my real-time database, which is not a pattern you have to do, but it's something that can certainly be convenient. So that's why I'm using admin ref here, just as out of convention. And then I'm going to write the transcribed text as well as the language. So with that written, it's going to write the transcription to the real-time database, and I can signal the next thing. Oops. So this is where the pattern I use a lot when I'm using Cloud Functions to solve these problems. I can chain them together. So I've just written a transcript down, which is not yet translated. It's still in the original source language. But what I want to do is I want to hear it. I want to have an event that I can trigger it to send it to the translation API. But I don't want to have one big monolith of code. I want to break it into pieces. So what you can do is you can have Cloud Functions that kind of chain together. Either they will send an event to the next one directly, or in this case, I'm sending an event through something that changes in the real-time database. So this is another write event handler on the transcripts node. See, where was I? C6. Pasting in another snippet of code. So what this one's doing is it's doing the same thing we did above. I'm going through and I am unpacking the data, and I've hard-coded the languages that my application supports. And then what I'm going to do is I'm going to do basically the same thing I did before, except kind of like a promise-ified loop. What I'm doing is I'm mapping through all the languages I support, and then in parallel, I'm sending a request to the translation API for all of the languages I support simultaneously, because why do them serially? Why wait? there might be some client currently using that. And then, for each one of those, if the translation is successful, I'm going to write the successful translation to Firebase Real-Time Database. Currently, I drop the promise on the ground if it fails, but I could put an error handler here, like a catch, that would write an error event to the real-time database. So at the end of the function, because I just forked off a whole bunch of promises, I have to add promise.all to wait for all of them to finish running so I can finally exit the method. If I don't do this, the function will exit immediately, or maybe it'll never exit. It'll exit when it times out after like 60 seconds. So you want to make sure that you clean up all your promises when you do this and return an individual promise that terminates, that reaches the state transition at the end of your actual work. Otherwise, you can end up with unusual behavior because promises is crazy like that. It's still a language construct that I'm like kind of using effectively, but it is powerful. So let's go on back onto the slides. Boop. So at this point, I would deploy that Cloud function. I've already deployed it ahead of time to save a couple minutes so we can spend more time on the fun demo. But this is basically what it would look like. You use the command line interface to deploy the function. It's going to push up my functions to Cloud Platform, and they will be there ready to serve requests. If it has a webhook, it'll also tell you what the address of the webhook, the web trigger is. So with that done, let's all play with the app together. So I'd like all of you, whether you're home on the live stream or here in person, if you have a laptop handy or a mobile device, get it out, go to this URL, and turn the volume up all the way to the max. That'll make it more fun, I promise. And in the meantime, what I'm going to do is pull up, well, I'm going to go to it myself too, to show you what's there. You can pick a language on this web interface, a language you would like to hear me try to translate text into. And then I am going to write data to it from the mobile application. So let's see if this actually works. I'm going to attempt, while that's happening, I'm also going to show you the real-time database as it happens. So we'll watch the real-time database so we can see the function executions occur while this stuff happens. So I'm going to say something. Hello, world. I say that a lot during this talk. And hey, we saw the upload get written. You can see all the metadata there. The cloud functions are now running, transcribing it. It is transcribed. Hey, it transcribed it to text. And now it is translating it.
Hello, world.
Ooh, I hear a bunch of languages picked. And we see that it's translated in all of the different supported languages. And I can select a different language up here. I can even try and speak a language I don't speak. I'm going to try that. So I'm going to pick Japanese. Let's see how successful this is. Ohaya gozaimasu. So it went in, it uploaded again. We'll see if it successfully transcribed it.
Good morning.
Hey, I actually said something in another language. Yay, I did. Sometimes it translates to something else. So, did anybody pick a language other than the ones I showed on stage? A few hands went up. Did it actually successfully translate into those languages? Did it kind of make sense? Thumbs up everywhere? Wow. I guess I give it very simple phrases. Sometimes I'll try and speak something more complex and craziness will come out, which is pretty fun. But it definitely does stuff. So, what have we accomplished in the last 40 or so minutes? We solved a problem that I encounter in my daily life in the way I solve all of the problems in my life by writing a mobile application. We wrote it in Android with Kotlin, which is pretty cool. I love using Kotlin on Android. It's so much nice. It's so much nicer than Java. I love Java too, but Kotlin's a good fit for Android development. And previously, I might have done something like this, where I had to spin up a bunch of compute nodes. And this may be where, if I had taken this application and moved it further along in its life cycle, I'm probably going to end up spinning up compute nodes to do more development on certain parts of the back end. But it's certainly more fun to have an existing application that's working to start from before I start optimizing different components, using different training sets, maybe writing my own translation models, or actually doing the translation from audio instead of from text, which loses some of the resolution. And I presented a different way of accomplishing that fact and getting that prototype out the door. We took Firebase, we took a few of the backend components and a few of the client libraries and hacked up an Android app pretty quickly in not that much code. And then we wired it up to Cloud Functions so that we could use a couple pre-trained machine learning APIs so we could move quickly. So now this is where I I'll encourage all of you. I showed you my favorite recipe for hacking out mobile apps to solve problems in my life. I encourage all of you to give it a spin. There's a free tier for all of the Firebase stuff, and you can build a lot of these things. I think all the translation APIs and stuff, like that's the cost for those. There's free tiers for those as well. So you can get this working pretty quickly. So go build cool stuff. So we have a little time left if anyone has questions in the next 4 minutes. Also, if you're interested in running this yourself or giving it a poke or seeing the web application or an iOS version of the same app, they're all up there on GitHub. Or rather, that goes back to my webpage. So it goes back to a webpage, miming.com/z2a. And there's slides. All the goodies are up there. So any questions? None. Well, if you have any questions, I'll be hanging out. Just come poke me in the hallway, and we can chat about serverless mobile application development and cloud APIs and stuff. So thanks so much for spending part of your Friday with me. Have a great rest of your conference.